podcast for Medical Biotech. For today's topic, we'll be taking a look into tuberculosis and its current diagnostic techniques and their improvements. Tuberculosis is a communicable disease caused by Mycobacterium tuberculosis complex. When a person with active lung TB sneezes, cough or spit, the contagious and airborne particles can infect others. Almost one-third of the world population has latent TB, and in immunocompromised state, it can become a full-blown active TB. TB symptoms depends on the TB type contracted, but in general, unexplainable weight loss, lack of appetite, chills, night sweats and fever, weakness and cough can be seen. Statistically, TB mortality rate worldwide recorded a downward pattern, but even at its lowest in 2017, 1.3 million deaths in HIV-negative patients and an additional of 300,000 deaths in HIV-positive patients was recorded. This shows that TB is still one of the top 10 causes of death worldwide. For new TB patients, they are treated with first-line drugs isoniazid, rifampicin, pyrazinamide and ethambutol in 2-month intensive phase, followed by 4-month continuation of isoniazid and rifampicin. It is vital that the patients take several TB drugs following the time period given, as failure to do so will result in them developing either rifampicin, multi-drug or extremely drug-resistant TB. Treating these types of TB is much more complicated, involving first and second-line drugs from groups A, B and C, or new generation drugs such as betaquoline and delamanid from group T2 or other agents from group T3. Prevention of TB involves identifying and treating active TB patients with drugs, cough etiquette and TB infection control in public places such as clinics and hospitals, preventing latent TB patients from developing active TB, and BCG vaccines compulsory for all newborns to protect them from contagious adults.
Now, I will explain about the current diagnostic reagent used for TB and its efficiency. So, are you ready? The reagent used are PPD, carbulvaxin, and auramine O. The first one is PPD. PPD is purified protein derivative. It is used in tuberculosis skin testing. The resulting reaction is read between 48 and 72 hours. The positive result shows when there is an induration at certain range of length in millimeters. The efficiency of using this reagent are it can use to detect MTB infection and also can evaluate the prevalence of latent TB infection. The second reagent is carbulvaxin, which is used to stain the acid-fast bacilli. The positive result shows when AFP appears red against the blue background under the light microscope. The efficiency of this reagent are it has an affinity for mycolic acid in bacterial cell wall and also a fast method to detect the presence of AFB. The next is auramine O. The dye will stain the acid-fast bacilli. The positive result can be detected when there is a presence of fluorescent bright yellow green. And when using auramine rhodamine, the fluorescent reddish orange will appear. The efficiency of using this reagent are it is faster detection of AFP, and with the use of direct fluorescent microscopy, it can detect about 9.29% of paucibacillary sputum samples.
The current diagnostic techniques to detect tuberculosis are TB culture test, direct sputum smear microscopy, gene expert, and TrueNet. First, TB culture test. In this test, the specimen of bacteria will be cultured on solid media known as lower stand Janssen medium. This medium is perfect to detect Mycobacterium tuberculosis because it can inhibit the growth of bacteria except for M. tuberculosis, while the glycerol that contain in it will enhance the growth of M. tuberculosis. TB culture test has its pros and cons. The advantage of using TB culture test is it can automatically detect M. tuberculosis growth. However, the growth of M. tuberculosis will take 4 to 8 weeks until we can observe the result, and it also prone to contamination. Next, direct sputum smear microscopy. Sputum is collected from the patients by coughing up sputum from deep inside of lung. The smear of sputum specimen will be stained with Ziehl-Neelsen and be observed under light microscopy. Acid-fast bacilli will appear as red against a blue background, but this test alone cannot differentiate between the mycobacterial species. Third, GeneSpert. GeneSpert is a cartridge-based nucleic acid amplification test for simultaneously rapid tuberculosis diagnosis and also a rapid antibiotic sensitivity test. It can diagnose the presence of TB bacteria DNA as well as testing for resistance to drug rifampicin. So, how does it work? The GeneSpert will detect the specific DNA sequence of M. tuberculosis and rifampicin resistance by polymerase chain reaction. GeneSpert will purify and concentrate the M. tuberculosis bacilli from sputum samples. It then isolates the genomic materials from the captured bacteria by sonication and amplifies the genomic DNA by PCR. The advantages of GeneSpert are it can provide faster results and can identify rifampicin resistance. However, it might be costly and requires stable electricity supplies. Lastly is TrueNet TB test. TrueNet TB test works by rapid detection of TB bacteria using polymerase chain reaction technique, while any resistance to rifampicin is detected by doing reverse transcriptase PCR. Unlike GeneSpert, TrueNet is operated using battery for the extraction of DNA, amplification, and reading the presence of specific genomic sequence.